Do you want to reduce your energy bills by barely affecting your frame rates? If so, this video is for you. The RTX 4090 has a default power limit of an eye-watering 450 watts. Insert scary RTX 4090 Ti noises here. So the question is, how much can we reduce this power limit? And what effects does it have on your frame rates? Now, the benefits aren't just that your power bill will be less, so even if you're super wealthy, this video still may be useful, because in lowering the power limit, you will also reduce the noise of the card and also the heat output as well, which can be particularly useful, for example, in sunny old England, where despite the fact that the temperatures do get pretty warm in the summer, well, all of our houses essentially are built with insulated bricks, and for some reason or another, well, air conditioning is not exactly a standard part of many UK houses.
We'll get into the benchmarks and results soon enough, but first, let's lay the groundwork for our experiments. The RTX 4090's power consumption naturally will differ based on various workloads. Therefore, despite the 4090's default power limit technically being set to 450 watts, in many games it will hover under this value, sometimes by quite a lot, sometimes a smidgen. This can happen if you're CPU bound or other factors causing the game or application to not fully max out the RTX 4090's AD102 silicon. As you can imagine, this bodes well for our endeavours. I wanted to keep this video as accessible as possible, and speaking broadly, there's many approaches to reducing power consumption on the card, including stuff such as undervolting, which has become pretty much the best friend of Radeon owners for the past couple of generations. I decided for our approach I wanted to focus on power limit only. There's a couple of reasons behind this. The first is that it's relatively easy to understand and for newbies to do. And the second reason, Nvidia's own GeForce Experience software provides the tools to adjust this power limit on the fly, so you can easily monitor the impact on the title and there's not really much setup. There are other methods for playing with power limit, including MSI's Afterburner, which you may prefer if you don't want to create an Nvidia account or choose to not install their software. Although GFE is installed with a default driver installation, you can tell the software to not install this specific thing during a custom installation. Honestly, a combination of undervolting and power limits can achieve great results, particularly on AMD, but we're going to be focusing on keeping things as simple as possible here. The front of Afterburner's GUI is simple enough, but digging deeper we also have more advanced tools available, such as for undervolting. You can access undervolting controls with Ctrl+F, and you're essentially able to adjust the curve, which allows you to edit the voltages at a specific frequency. There's a number of tricks you can use to improve navigability and usability, such as locking a specific voltage with Ctrl+L, using Shift plus left click to select a number of points, Alt plus click to move the entire thing, and Control plus left click to adjust the point more finely, and so on. You will definitely need to play around with undervolting to find the best values for your card, and it can vary a lot because of numerous factors. We'll also be conducting all of our tests at 4K of course, to help focus the burden of the work on the graphics card. We'll be using an Intel i9-13900K, sent by Intel as the processor of choice here, wrapped up with 32GB of RAM, sent by Corsair, our Asus ROG Strix Z690 Gaming DDR5 board as the platform, thanks to Asus, a Deepcool 360 AIO to keep the 13900K's temperatures under control. Thanks to Deepcool for sending that over. We're doing a review of that very soon. And we're running this with a Corsair RM1000X PSU. They actually sent over an 850 variant of the same series, but true story, this actually prompted me to pick up the 1000 watt variant you're seeing here by myself. It also goes without saying that the tests are run on Windows 11 and appropriately latest versions of the software and the drivers. As for the RTX 4090, it's a GameRock card made by Palette, which was bought thanks to all of you providing support on the channel. It's been a solid card for me at least, with the fans largely unobtrusive in terms of noise, and I've also not heard much coil whine. It's certainly not a card with as many bells and whistles as the more expensive models, but it's been very solid. So, let's get started. For those unfamiliar with the GeForce Experience app, here's what to do. Run the application, of course, and under the Settings button, the cog icon, ensure that the in-game overlay is enabled. You can also click on Settings and go to Keyboard Shortcuts, and under Performance, I've given the performance menu, Alt plus P is a shortcut. The P stands for performance. I'm a genius! You can also access it via pressing Alt plus Z and navigating to it manually, should you so desire. Load up the Performance tab, and I suggest clicking the cog icon next to the Performance overlay, and choosing Advanced you have more verbose and detailed readings. You can also set a different position on screen if you so would desire. And now we've got access to Power Maximum. The 100% value is the default value. Some 4090s will allow you to go higher than 450 watt TDP, and that's due to a couple of things being true. One, the manufacturer uses a custom BIOS allowing their values to be raised, and they're using a different type of 12 VHPWR than our card here. The basic difference is that there's 4 PCIe power cables linking it rather than the 450 watt limited cards of just 3. You can bypass this limit with a 450 watt only card by flashing the BIOS and buying a separate cable. Perhaps I'll cover that in another video. For those wondering, you cannot just say flash this card with a BIOS and then running a higher limit, let's say 500 watts, because the card essentially detects the attached cable and tells you, nope, you're being a naughty panda. You cannot do that. Getting back to the reductions though in the power limit, now we've got access to these adjustments, you can then load up a game, ideally a demanding one with similarly demanding settings, and then start playing around with the power limit with the application running. You can simply tap Alt plus P, assuming you've assigned that as a shortcut. If not, you can go with Alt plus Z and then a couple of clicks. If you're running Afterburner, well, you load up the application and then set the power limit and then of course adjust it as you would like. With that said, let's have a look at the results and then discuss. Righty-ho! As a general statement, I think it's fair to say that cutting the power limit to 90%, which has the RTX 4090 running at around 400 watts, means no performance degradation at all in the majority of games and applications. And even a heftier chop to the card pulling just 340 watts at around 75%, again, largely keeps us on an even keel. You will notice benchmarks start to change a bit, but in general, I would say that the games, you wouldn't notice them playing that much differently, especially in titles with DLSS. Performance though starts to reduce more significantly, of course, at around 50%, and that's where we start to really notice clocks start taking a dip. And under 50% value, especially around 30%, well, yeah, 800 MHz is pretty common. Amusingly, some games still will hit a playable average FPS with these settings, but I certainly would not vouch for frame times and minimum FPS stability. As a bit of a trick, you can also use MSI's Afterburner, yeah, we're getting back to that, to manually raise the core clocks, of course. Now, in my experimenting with this, honestly, I didn't have much luck when the power limit was set really low, such as 50% or less. To use a simple analogy, there's just not enough gas to push the engine, so to speak. But in control here, you can see that at 90% PL, the clock was actually running slightly higher than stock in the same scene, and at 75% we actually managed to hit an additional 80-ish MHz. These results will definitely vary on a game-by-game basis and setting-by-setting basis.
So for your bank balance then, and the fact that we're going to be soon moving into warmer months, messing around with undervolting and power limits is certainly a great way to go. I think it's going to be very interesting to see how higher end cards as well as lower end cards from Nvidia start scaling. For example, when we finally get the RTX 4090 Ti launching, it's going to be very interesting because the rumor is it's going to be 550 watt TDP, possibly a little bit higher. As for the lower end cards, well, mostly the principle is the same. So for example, if you're planning to pick up an RTX 4060 or even an RTX 30 series card, then you can apply a lot of the same principles there. Let me know down below in the comments what you've been doing with your own graphics card, especially with AMD hardware. I'm quite curious, especially with the RX 7000 series. And if you found this video helpful, well, it's YouTube. You guys know what to do. Help the engagement by clicking stuff back down below. And I'll see you soon. Take care of yourselves. Bye for now.